Today we're going to learn 2 more numbering systems. I will say that today's systems are a little bit harder than yesterday's because yesterday's systems, they at least kind of counted like us. They still did things in 5s and 10s, which we're pretty familiar with. In these 2 systems, they counted totally different. And part of the reason why I still want to teach this is because a lot of times things seem like the right way or the best way to us just because that's the way we do it. So then when we look at these other numbering systems, we're like, why on earth would they do it like that? It's so hard, it's so confusing. But they would have thought the same thing about ours. And so I think that's like just a big cultural understanding of just because we do it this way doesn't mean it's the right way or the best way. It's just our way of doing it. So these are going to be a little bit harder to learn than our systems from yesterday, just because they are going to be different than our system. So the first one is the Babylonian system. Babylonians only used 2 different symbols, one symbol to count 1s and one symbol to count 10s. So they still kind of were thinking about 1s and 10s, but they used a place value system that was based on powers of 60 instead of ours is based on powers of 10. So like our decimal places, we count them tenths, hundredths, thousandths, those kind of things. So we based on powers of 10. They based on powers of 60. And the reason why they did that is because that's how the clock works. And that's how they then set up their time and their calendars. They figured numbers should be the same type of thing. So they have their numberings counting by powers of 60. The chart shows kind of their fancy handwriting of it way. I'm not going to write it in the fancy handwriting way. I'm going to write them out more like it looks in that first example, where it's like you can tell there are 3 of these and 2 of these. Instead of once they start combining them, it's kind of hard to tell how many of everything there are. But I just wanted you to be able to see that that's actually kind of how they wrote it. It was more condensed, so it didn't take up as much room, but it's harder to read, I think. So the big spaces have meaning. So it says convert, and there's 2 little ones there, so that's worth 2. And then on the next one, there's 3 of the 10s and 1 of the 1s, so that's 31. And in the next space, it'd be 23. Now, how we turn this into a number that would make sense to us, since they use powers of 60, is I always start at the end and work my way back. We're going to do 23 times 60 to the 0. Add that to 31 times 60 to the 1st. And this is 2 times 60 squared. So the last place is always the 0, and then you just kind of count back as far as it goes. Those spaces tell you that it's a new place value, so that's where we count it by our powers of 60. Okay? And then we can type that all into the calculator, just as it is, and get our answer that in our kind of a number, this turns into 9,083. Remember, our numbers are Hindu Arabic, so when you see that, don't think like, oh, great, it's another one. That's us. That's the way we do things. A problem comes in with understanding Babylonian numbers, and we don't know how they dealt with this problem of, like, what if really all they wanted was, like, this section, and this part wasn't here, but they don't have a symbol for 0. So we always kind of assume that the last thing we see means the power of 0, but what if it was really supposed to be the first power? And this part of the number just wasn't there, but they don't have a symbol for 0. So we don't really know how they dealt with that. They must have had some way of understanding. There must be something in the way that they hashed things out that would let somebody know that, but we don't know what it was. So for us, we will always assume that the last one is the 0 power and count our way up. But there is some ambiguity there that they must have had something else going on in their number system that we still don't know or understand. All right? Questions? All right, so then working backwards now to turn it the other way. to turn it the other way, what we have to do is figure out how many powers of 60 can we fit inside of here. So this is where your calculator is going to become super important to you. So what we're going to want to do is take our starting number and divide it by a power of 60 we think might work as big as possible. So we could try dividing it by 60 cubed. Maybe that works. I don't know. So we're going to take 12 to 21 and divide it by 60 to the third power, and we get a decimal, like 0.0 something, not even a whole number. So that was too big. So it must be that 60 squared is the biggest thing that can go into this. And that goes in 3 times, but it's 3 point some stuff. We need to know what the remainder is. So to figure out what the remainder is on your calculator, so I got a decimal, 3.394, blah, 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 blah. I'm going to subtract the 3 from it, so I just have the decimal portion. So now my calculator is reading 0.3947, blah, 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 blah. Multiply that by 60 squared, which is what we divided by, and that'll get us back to our remainder portion. Okay. So we want just the decimal portion of the division, and then we want to multiply that by whatever the denominator was, so 60 squared. Okay. So our original division gave us like 3.39, blah, 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 blah. Then on my calculator, I go minus 3, so I just have that decimal part, and I multiply that by whatever the denominator was, which was 60 squared, and that gives us our remainder. Okay. So now what we're going to do is take that remainder and divide it by the next lower power of 60, so 60 to the first, or just 60. So we do 1421 divided by 60, which is 23, but it has a remainder as well. But again, this time on the calculator, I got 23.68, blah, blah, blah. So I'm going to subtract 23, so it just gives me the decimal part of it. And then I'm going to multiply that by 60, since that was our denominator. And that gives me the remainder portion, which is 41. We don't have to divide by 60 to the 0, because what is 60 to the 0?
0.
Close.
1.
1. Anything to the 0 power is just 1. So dividing 41 by 1 is going to be 41. So once you divide by that first power, you're done. Now to turn this into our symbols, the important values here are our first value, our second value, and our very last remainder. Okay, so whatever those whole numbers were in the front, and then that very last remainder are what we're going to want to write out in symbol form. So, erase my scratch work over here, and I end up with 3. So I need 3 ones, and then a space, 23, and a space, 41. Oops, 41.
What if your initial number is less than 60, so you don't have the power of 60?
Then it would just be that very last remainder. It would just be this thing, and you would just do
So you just
however many
write
symbols you
41
needed.
or whatever?
Yep.
Okay.
Yep, then it's a lot easier of a problem, because you don't have to do any dividing or finding of remainders or anything. Okay? Does that make sense? So like I said, their numbering system's a lot harder, and you're probably like, oh man, all this dividing by 60, and like it seems hard to think of, like counting by 60s. They must have been really good with 60s, right? Like that seems like a weird number to count powers of. Powers of 10 are easy because they just add another 0 at the end. But powers of 60, like, yeah, it's just a different way of thinking. The Mayans also had a different way of thinking, and their way of thinking was really different. They used these symbols from 0 to 19, and then they started doing place value things. So the Babylonians had symbols for, they didn't have 0, but for 1 up to 59, and then at 60, that's when other stuff started happening with place values. The Mayans only went up to 19 before they started dealing with place values, but they understood the idea of 0. Babylonians, to our knowledge, didn't understand 0. They had no concept of what a 0 was. At least they didn't in their number system. For the Mayans, they used this numbering system that's at the bottom here. For the lower ones, I got to scroll up a little bit so you can see the bottom of that. They started with a 20 to the 0, and then 20 to the first. But instead of then going 20 squared, they brought in an 18 times 20 to the first, and then 18 times 20 squared, and then 18 times 20 cubed. The reason was 18 and 20 were both important numbers for them in terms of their calendar. So they had 18 months in their calendar, and each of those months had 20 days. So that's why they used both 18 and 20 as important numbers in their system. So we start at 20 to the 0, 20 to the first, then we bring in the 18, but still keeping that 20 to the first, and then we continue counting up that 20 with the 18s in there. So it's a little bit trickier, but we can do it. And they had a 0, so that's good for us that we don't have as much ambiguity there. So what we need to do is recognize what each one of these symbols are. So 2 lines together is what? 10. And then a line and 3 dots.
13.
Only 1 line and 3 dots. 8. And then 2 lines and 1 dot. 11. So you can find each one of those place values. So a dot means 1, a line means 5. So those are constant for us. Should be easy to learn to recognize and remember, but remember you don't have to memorize all these symbols. They'll be printed on your quiz for you. Then, starting at the bottom, we multiply that by 20 to the 0, which is really just 1. Okay, so there's really nothing going on there. Then the next one up, we multiply by 20 the first.
So it's the same kind of thing.
And then above that, we multiply by 18 times 20 to the first. Okay, I'll tell you on your quiz, the symbols are on there, but this numbering system of remembering that they did 20 to 0, 20 to the first, 18, 20 to the first, that is not on your quiz. So you do have to understand how their numbering system works. You just don't have to remember their symbols. Same thing with you'll have to remember that the Babylonians were working with 60s. Okay? So those things you'll have to remember for the quiz, but not the actual symbols themselves. Then we can type this all in the calculator.
Why do we start with that 18 times 20 to the first?
Because it's 3 rows of information, and so we use the bottom 3 rows of the chart there. So then you just type it all in the calculator. 10 times 18 times 20 plus 8 times 20 plus 11 times 20 to the 0, which is really just 1. So you don't ever have to type in the 0 powered thing. And we get 3,771. Questions? We have one more example that's like this. That symbol, it looks like 3 dashes because the font wouldn't let me do anything else. I intended it to just be like 1 line, but it wouldn't let me just do 1 line. So that 1 line is worth how much? 5. That little seed is their symbol for 0. Then 2 lines and a dot. And 3 dots. We start at the bottom by a power of 0. Count up 20 to the first. 18 times 20 to the first. And then 18 times 20 squared. So the 0, we don't really have to worry about that because that's just 0, right? So we don't have to bother typing all that in the calculator. Whenever it's 0, it's not going to affect the final answer. So we just type the rest of it into the calculator to get our final answer of,
You just add them all up.
yep, just add up each of those rows and we get 36,243.
Wait, so the middle one just goes away?
Because it's a 0.
Oh.
So in general, we don't just ignore it, but if there's a 0, we can always ignore 0 because 0 times anything is just 0.
Yeah.
Right? Questions? So our last one here, and this is where I think these problems are harder than the other ones, is doing the division and finding the remainders. We have to figure out what's the best thing to divide this by, and it's just some trial and error. So the first thing we might want to try to divide it by is like, and you better use parentheses here, okay? We're going to divide by all of maybe 18 times 20 squared. Okay? And we can see what that does, but make sure you put parentheses around that 18 and 20 squared. And that was a good first guess because I only got 1 point something, so I know that it's not going to go any bigger. If it's a big number, I probably could have done more, so then I would have to step it up. If it's just a decimal, then it was too big to start with. But a 1 is a really good sign that this was the right place to start. Okay. So I got a 1, and then we have to find that remainder again. So to find the remainder, we subtract off the whole number part, so we subtract off the 1, and then multiply by what we were dividing by. So 18 times 20 squared, which is 295.
Oh, you multiplied the 0.04.
Yep, multiply that decimal part, the 0.049, blah, 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 times 18 times 20 squared. Then I'm going to take that 295 and divide that out by the next step down, 18 times 20 to the first, or just 18 times 20. Again, make sure to use parentheses because we're dividing by more than one thing and we want to do the whole division. And when I did that, I just got a decimal part. So that means that's a problem, or it's, in terms of the Mayan system, a 0. So then we're going to go down to the next step. Their next step was just dividing by 20. The 18s fell out after that point. So 295 divided by 20 is 14.75, or 14, and a remainder of 0.75 times 20, which is 15. Our next step down would be dividing by 20 to the 0, but that doesn't make any sense really because it's just dividing by 1, so we don't have to bother doing it. So we're done dividing at this point. Once you get down to that last first power, then you don't have to worry about dividing anymore. So the parts of this that are going to create our number are the 1, the 0, the 14, and the very final remainder. So we're going to have 4 rows of symbols. Our first symbol is a 1, so it's just a dot. Our next symbol is a 0, so it's that little shell thing. Then our next symbol is a 14. And our final symbol is a 15.
Can you show me how you got 15 again? And the remainder?
Yep, I did 295 divided by 20, and that gave me 14.75.
Yeah.
So I subtract out the 14, so I just have the decimal part of 0.75, and multiply that by 20. Whatever the denominator was is what we multiply back in.
Okay.
Okay? Questions?